Hello, today we'll be doing the problem called Hoppable. Given a integer list of nums where each number represents the maximum number of hops that you can make, determine whether you can reach the last index starting at index 0. So in example 1, you cannot reach the end because there are no steps that you can take to the last index. In example 2, you could take step 2 and then go to step 1, and step 1 will allow you to take 4 steps to step 0. And in example 3, you cannot reach step 0 because you only take 1 step from 0 to 1 and 1 step to 2, but at 2 you cannot no longer take any steps. So the method is, can we bring this goalpost closer? And in this case, at this particular position, we cannot bring ourselves any closer to our solution. We are just too far away to make us to get to our solution. So it's a DP greedy type of problem, and so this basically means we're going to go in reverse and see if at each particular position can we set that as our new goalpost, and if not, then we do not move the goalpost, and we'll try to reach the goalpost from a different point, from a different number. Yes. So here's how it will go. So we'll set a goalpost at equals nums, lang nums -1, and for I in a range, lang nums -1, all the way down to -1, which is our 0 point. By going in reverse, we can set if the I plus the nums of I is greater, that's right, greater than the goal, then greater than the goal, then that means we have reached that point. If it's less than the goal, then we have not reached the point. If it's equal to the goal, we should reach the point as well. So the goal is now equal to I. That's because we can reach that goal from I. So all we need to do is reach I. So now we return the goal is equal to 0, and we should have a good answer. Let's run it, and it's accepted. And let's submit, and looks like we're good to go. We have a success here, and yes, this is a interesting type of dynamic programming question. It is pretty tricky when you immediately think, oh, prototype, I'm gonna map the dynamic programming pattern to this particular problem, because I can see sub-problems already. I can see problems going back from the last item to the first item. We can already see a tree structure going on immediately. This picture where we can see starting at the 0 step, we can take 2 steps. We can either get to the we can get to step 1 or step 2, and from step 1 we can take steps to 2, 3, and 4, right? And we can go from step 2 to nowhere. But the point is, you see that there's a tree structure already built up, and we want to see, can we reach step 4? Is that possible? And so we would want to build up our dynamic programming already. This is quite a tricky problem, because we're out here trying to map our what we have done before to previous problems, and if you don't read clearly what the problem is asking for, we would be solving extra work. We would be doing extra work to solve this problem, and we will not provide the most optimal solution, because this is the height of the tree, right? At least the height of the tree, and we're doing, of course, we're doing for each number, but we'll still be using extra space, which we're not here. So even if we store everything, right? We store 0, 1, 2, 3, and 4, all those steps, right? It will still be using extra space. So that's how that's something we need to watch out for and think about, and really read the problem clearly before we map our solution to the problem, and ask, what is actually the question here? What is our goal in this particular problem, and what can make this problem easier for us? Let's simplify our problem first. The lesson here is simplify the problem first, to the point where it no longer can be simplified, and then solve the problem. That way we can come up with the most simple answer to the problem, rather than answering a harder problem. And I think that wraps up this video. Thank you very much for watching. If you enjoyed the video, like and subscribe. If you have any questions, please comment below. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.